Hello, welcome to Cybersecurity Workshops. This is David Raymond. I'm the director of the Virginia Cyber Range. The purpose of these workshops is to provide relatively short, 30 minutes or so, introductory topics on cybersecurity. And we're going to start out with some a series of lessons on introduction to the Linux command line. So we'll go ahead and dive right in here. This lesson and the following few lessons will be from a course developed by Matthew Vogel, who's a faculty member at Tidewater Community College. And the first module in his course is Basics of Using the Command Line Interface, and lesson 1 is Bash Basics. So for instructors that are going to use this content in their class, let me just show you real quick how to get to it. So instructors, if you go to the virginiacyberrange.org webpage, then go to courseware. If I search on command space line, you'll see a course entitled Introduction to the Command Line Interface. If I click here, this is the course, and the course is eventually going to consist of 10 modules, so a very robust course on using the command line interface. Right now, a total of 3 of the modules have been completed and uploaded to the Virginia Cyber Range courseware repository, but even in just those 3 modules, it's a lot of great introductory command line instruction. And so I'm going to go down to the first module here, Basics of Using the Command Line. And as usual, you'll see a brief description, some learning objectives. First couple of lessons are here. I'm going to go into the Bash Basics lesson. And there's a lesson plan, there's presentation slides. I'm going to use those presentation slides in this talk. And then there's a lab exercise. So I would encourage teachers, instructors, faculty members, if you're going to use this content to go through the lecture or use this recorded version of the lecture with your students, and then have the students work on the Bash Basics lab exercise. All right, so we'll go ahead and start here. Bash Basics Introduction to the Linux Command Line Interface. So some lesson objectives. We're gonna start by talking just a little bit about Linux, so we know, what Linux is, why we use it in a cybersecurity context. We'll talk about the a little bit about the command line interface itself. We'll talk about Bash, and then we're going to talk about the first few commands that you might use in the command line interface. So I'm going to talk about these, and I'm going to toggle to a Virginia Cyber Range exercise environment and do a little hands-on. And I would recommend that if you're listening to this lecture at home, if you're using this in class, then you should sort of play along with me, right? So pause the discussion as necessary, go to the Cyber Range, open up a Cyber Basics environment, and do some hands-on with some of these commands, just so you get a feel for how they function. And there's a list here of the commands that we're going to talk about today. So we'll start at the beginning, right? So what is Linux? Linux is an operating system. So it's software that runs on a computer that serves up the application software that we might want to use, the sort of the general purpose tools that are provided by the computer. And so another example of an operating system is Microsoft Windows. Another operating system is Mac OS. So there are different operating systems used by different people for different things. A lot of it is about, how do you decide which operating system you're going to use? Well, a lot of it's about personal preference. And then, of course, a lot of it has to do with what software and applications will run on that particular operating system. So for example, a lot of businesses use the Microsoft Office suite of tools, which includes Microsoft Word, Microsoft Excel, Microsoft PowerPoint, et cetera, and that suite of tools works great on a Microsoft Windows operating system, so a computer with Microsoft Windows installed. You can also get a version of Microsoft Office for Mac OS, so for Apple devices. you cannot get Microsoft Office for Linux, right? So if you're in an office environment and you need to be able to use the Microsoft Office suite of tools, then Linux is probably not your best choice. But there are lots of other great reasons why you might choose Linux, and we'll talk about those as we go along. Linux, the term Linux is actually the name of the operating system kernel, and the kernel is, as this bullet mentions, is the heart of the operating system. So that's you know, sort of the basic bit of code that keeps the operating system functioning, and then you know, on top of that kernel are added things like the user interface. So that's what we see when we open up the desktop environment, and you know, the menu system, and you know, and the menus and the terminal window and the web browser, all that stuff. You know, the user interface is you know, separate from the kernel. The device drivers, the things that make your printer work and your network interface card work, and all these, you know, different bits of software that make the peripherals on your computer work, those are separate from the kernel. Those are called device drivers. They drive the devices that you attach to your computer: mouse, keyboard, printer, etc. So so the kernel is the very sort of basic heart of the operating system. And the Linux kernel was developed by a guy named Linus Torvalds back in the early 1990s, and it's a bit of an interesting story if you're into this kind of thing. You know, Linus Torvalds, you know, wanted to have an open source operating system that he and his colleagues could use, and the operating system of the day back in the 80s, early 1990s was an operating system called Unix. And this was you know, proprietary software that was developed by a couple of large companies, IBM, AT&T, those kinds of folks. There were a couple of different, slightly different versions of Unix, but this was not open source software. So Unix was code that was not, you know, you couldn't see the source code. You know, the average user couldn't get access to the source code to see how that operating system really functioned. And there was a little bit of mistrust in some of the user community that, you know, they didn't want companies dictating the kinds of software that could run on a general purpose computer. So Linus Torvalds took it on to create his own operating system kernel, and he made the functionality very similar to Unix, not the same, but very similar. So when he named his operating system, he took the LI from his name, and then he took the Nix from you know, sort of changed it a little bit, but the Nix really sort of comes from Unix. So he called his kernel Linux. So that's where that name comes from. Kind of an odd name, but it's this mishmash of these two different words. And so he, you know, developed this very heart, the original kernel back in the early 1990s. And now over the years, there's a whole team of people around the world who help develop the Linux kernel and who create these different resources and tools that can be used along with the Linux operating system. So it's not one person anymore, it's a whole team of people, but it's very much controlled by Linus Torvalds still to this day. And Linux has this notion of distributions. So we mentioned that the Linux kernel is sort of the heart of the operating system. So if you think of, you know, in the middle, there's this kernel called Linux, and then you bolt on all the other stuff, like the user interface and device drivers for your printer and your keyboard and your mouse, and you know, there's just all kinds of other pieces of software that make this thing run, and those are all sort of connected onto the outside, and those are part of the operating system. And then there's this weird looking one here. I'll erase that and fix it. And then on top of that, you add your applications, right? So you might add your web browser. That's going to get bolted onto the outside, and then you might add your email, whatever your email program is, and so so all this stuff in the, you know, in between the Linux kernel and the applications, that's all the other components of the operating system. And people want to have different stuff in there for different purposes. And so there are lots of what we call distributions of Linux. So they're separately named versions of Linux that are maintained by all kinds of different people, and it's sort of the nature of this idea that the software is open source. You can modify it as you need to, and so people modify it to suit their particular requirements. And so I guess I talked about most of these bullets, and there's a website called distrowatch.com. Let me see if I can go to distrowatch.com. And we'll just take a quick look. Okay, here's distrowatch.com. It's really sort of surprising when you look at this. So this is a website that's all about different Linux distributions. Got daily news on different new events. And over here on the right side, what you see, there's this page hit ranking. So this is page hits on information pages about a variety of different Linux distributions. And so they have the top 100 listed here, the top 100 Linux distributions, and that's not all of them by any means, right? So there are hundreds of different Linux distributions created by different people for different reasons. Lots of them are developed by a specific company. Amazon has their own Linux distributions. Large companies have their own specific distributions for their particular use. And it's this extensible nature of the Linux operating system that makes this possible. So some of the very most popular Linux distributions, some that you may have heard of, are Ubuntu. Ubuntu is probably the most popular sort of desktop operating system version of Linux that's out there. It's pretty widely used by people who are able to use Linux as their desktop environment. It's user friendly. It's got a nice user interface. It's pretty well supported. So Ubuntu is definitely a popular one. Debian is another popular Linux distribution. Fedora. Fedora is actually an open source version of a Linux distribution called Red Hat. Red Hat. So you may have heard of Red Hat Linux before, or maybe not, I don't know. But so Red Hat is actually a company that has their own Linux distribution, and they provide user support. So if you're going to use Red Hat Linux, you pay for it, but you're not, and I should mention that most of these you don't pay for, right? So you can get a free copy of Ubuntu Linux, free copy of Debian, Fedora, all these are free. You can go to the web pages listed here. You can download your own copy of the operating system. You can install it in a virtual machine or on a computer and use that operating system. Whereas a system like Windows, you have to pay a license fee in order to use that software. Well, with Red Hat Linux, there's a license fee. The license fee technically isn't for the software itself, but it's for the support that is provided by the company Red Hat. And so, if some large company is going to install a suite of Linux throughout their organization, but they want some user support, they might go with a company like Red Hat who will provide support. So if they have a problem, they can call somebody to get help. That doesn't exist in these other free Linux distributions. If you're using Ubuntu Linux and you can't get it to install on your particular computer, for example, you can't call Ubuntu and have them help you. It's just they don't provide that service because it's free, and they just don't have the support infrastructure in place. There are lots of a lot of these have pretty robust user communities, so you could Google your problems and probably find all kinds of websites that might point you in the right direction, but a lot of the maintenance is really sort of on your own. So these are some of the popular distros, and in this series of discussions, we're going to use a distribution called Kali Linux. Kali Linux is based on Debian Linux, but it's got a bunch of tools installed that are used by penetration testers, which are cybersecurity experts who try to gain unauthorized access, test the security of other people's networks by gaining unauthorized access to those networks. Usually, they're usually contracted to do that. Okay, so how do I get Linux? It can be downloaded, right? So I just provided that list of URLs to different websites of different distributions. You can download Linux from one of those websites, and then you can install it directly on your computer, or you can use you can install it in a virtual machine. So you might use there's software called VMware, which is commercial software that you can use to run virtual machines. Another very popular option is software called VirtualBox. VirtualBox is very powerful local virtualization software. So you can download VirtualBox for free. And if you just Google VirtualBox download, you can download VirtualBox. It's software that you can install on a Windows or Mac computer, and then you can run virtual machines of of whatever flavor you like. You can pick a Linux distribution and install it and run that operating system. And then another sort of environment where you might see a Linux operating system is in an online system like the Cyber Range. And so the labs we're going to talk about, this series of labs and this series of command line discussions are using the Cyber Basics environment in the Cyber Range. Okay, why Linux? This is perhaps a key aspect. Why Linux? Well, Linux is, we mentioned that Linux is open source, it's free, and it's completely tailorable, right? So if you were going to run a data center with, a bunch of websites, then you might use Windows. You might pay a license fee for every Windows operating system that you install across your tens or hundreds or thousands of servers. That would be very expensive, and Windows is not very tailorable, right? The source code is not open. The operating system code is not open. You can't change Windows to suit your specific needs. And what I mean by that is, in a server environment where you're serving web pages, you don't need all that user interface that you get with every Windows server install. There's a whole bunch of code that does nothing but provide a user interface. And if you're running a server, 99.9% of the time, you don't need any kind of a user interface. And so why should I have all that extra stuff taking up space on my hard drive, taking up space on my, in the memory of my computer when it's not needed? And in Windows, you can't change all that. With Linux, you can do whatever you want. You can create your own Linux distribution. You can install versions of Linux that don't have the command line, or I'm sorry, that don't have the desktop user interface. So it's very tailorable. It's very popular in the server space. So most web servers on the internet are running on top of a Linux operating system. If you think of large companies like Amazon Web Services, which runs huge data centers around the world and push all kinds of different software applications, those are all running on Linux systems. Many IoT devices, I would even say most IoT devices, run on Linux. Why? Because IoT devices require a very minimal operating system footprint. It has to be really small, and your IoT device, you generally don't need the user interface. So the people who create the software for these IoT devices, they can take away all the extra stuff that you don't need for your smart speaker, smart light bulb, whatever, and only incorporate the core required components. And so it's very popular in IoT. Linux is the most popular phone OS. So Android, you've heard of the Android operating system that runs on lots of handsets. That's a version of Linux. And hackers and pen testers use Linux, and a lot of that has to do with all this up here, right? If you're gonna to hack a website, if you're a malicious person going to hack a website, or if you're a penetration tester and you're going to try to gain unauthorized access to somebody's website, you need to understand how that system functions when you get there. When you get unauthorized access to the command line, for example, you have to know what to do, and so it just makes sense for you to use a Linux system, because using a Linux system is going to make you very familiar with that operating system and with what you're going to see when you get on a system. Linux is also, again, very tailorable, so I can install all kinds of cool hacker tools that give me access to components of the operating system that I probably wouldn't be able to get if I was running on a Windows system. So lots of reasons why Linux is really the operating system of choice for most cybersecurity professionals and most hackers and pen testers. And the tool, the specific version of Linux that is widely used, again, is this distribution called Kali, which provides a whole bunch of specific tools that penetration testers like to use. Okay, so we're going to log on. I'm going to log on to my Kali Linux virtual machine. I've got it all set up and running here. So I'm using the Cyber Basics environment. You could also do what I'm going to do today on a just a Kali Linux virtual machine environment in the Virginia Cyber Range. But I've got this Kali Linux system started up, and I'm going to log in. Okay, so here I am at my desktop, and I'm going to open a terminal window. So if I look at the menu down at the bottom, I have some different tools I can use. I have the terminal window. I can look at the file explorer. I can go to the web browser, etc. The thing I'm going to open up is my terminal window, and I'm going to zoom it a little bit so that makes this easier to see. Okay, so here I'm in my terminal window. And we're going to use the command line interface, right? Text only. So in this series of discussions about command line interface, all of our interactions are going to be entered using the keyboard. So we're not going to mouse around a whole lot. We're going to be using a terminal window. This is sort of old school. This is how we used computers, 30 years ago, before we had these windowed interfaces. All we had was the terminal window command line. That thing filled the whole screen when you booted up the computer. Okay, and we're using what's called the bash shell. So this thing that lets me type in commands is actually a program itself. It's a program called bash, okay? And it's a shell. So a shell is a program that allows you to interact and give commands to the operating system by typing them at the keyboard. Makes sense? In most modern Linux distros, the default shell is the bash shell. Bash. So it's kind of an odd name. You might think, where does bash come from? Bash stands for born again shell, which probably doesn't make it any more clear, right? So where does the name born again shell come from? Well, the original shell for Unix systems was created back in the 70s, probably, maybe early 80s, by somebody called Stephen Bourne, and he worked for AT&T. So remember, this original Unix operating system was created by AT&T. AT&T was one of the major players, and Stephen Bourne created this shell. You needed to have a shell in order to interact with the operating system, so he created this shell, and he called it it was SH was how you got to it. So the program that makes it run is SH. So you could do SH at the command line and get a Bourne shell, and it was called the Bourne shell because this guy Bourne created it. Well, when Linux came along, they needed, remember Linux was largely based on Unix, and they needed similar functionality. And the Linux kernel works very much like the Unix kernel in many ways. And so when they needed a shell environment, a command line environment, they couldn't use the Bourne shell because, again, that shell was proprietary part of the Unix operating system. And so they had to create their own version of a command line interface. And so they created this thing called the Bourne again shell, bash. So that's where that name comes from, Bourne again shell. A little bit of Linux history there. And it's one of various different shells, right? So there's one called the C shell, CSH. There's a couple of others, but it's very widely used on Linux. It's the default operating command line interface for most Linux environments. You can select other command line environments if you want to, but we're not going to talk a lot about that. Important thing about the bash command line interface is the prompt that you get, and that prompt is completely tailorable. We're not going to talk about that today, but you can change what that looks like. When you open a terminal window, you get a terminal prompt. The terminal prompt includes some basic information about your system. The first part is usually the username. So this is username, followed by an @ symbol. So username @ the next part is the host name of the system. In this case, the host name is this, and it just sort of repeats the IP address. But if this was your home system and you had named it, there's a way that you can give a host name to your system, and so that part names the host name. What comes next depends on the Linux distro. For some distros, it's the colon character follows the host name. For others, there might be a space. Next is the current location in the file system. So here I have student, so that's the username @Cali, that's the host name, colon, and then the current location in the file system. And how do I see what location I'm in the file system? Well, I can do this thing called print working directory, PWD. It tells me I'm at home student. That's my home directory, and the tilde is a shorthand for my home directory. Whoever, my username is student, my home directory is home student, and so the tilde is shorthand for /home/student. And that's all described here. After that, there's a $sign. If I'm logged in as a user, I get a $sign prompt. If I'm the root user, so if I'm an administrative user, then the last character would be a some people call it a sharp, some people call it a £. Nowadays, people call it a hashtag. It's the I'm sure there's an official name for it, but you get the hashtag symbol, and that indicates that you are operating as the root user. We'll talk more about that later on. Not particularly important right now. Most of what we're going to do, certainly in these early discussions, will be done as a non-root user, so I'll have a $sign prompt at the end. So that's the $sign thing there, right? So the first thing I'll do is the echo command. So we're going to start to get into the commands here, and so the first one I'll talk about is echo. Echo is a basic bash command that I'm going to use here to demonstrate how an interactive shell works. But you can do things with echo, like I can echo things to the out to the terminal window, right? So I can say echo hello world, and I get that, that phrase is going to be echoed to the terminal. Okay, that's kind of interesting. Why would I ever do that? Well, I may have a script where I have different steps in the script happening, and I want the user to be informed of a script is a series of terminal commands that are in a file that you can have the system execute, and I may want to sort of give the user a status of what's going on once in a while in that script. So I might have an echo that's going to echo something to the terminal window so the user knows what's going on. So I can put quotes around the thing that's echoed or not. So here's some examples: hello world with double quotes around it, hello world with single quotes around it. And I can use the echo command to send output to a file instead of to what's called standard out, which is back to the terminal window. And this is known as redirection. Redirection uses the greater than character to send the output to a file. So so my example here is echo hello world, and then I'm going to push it into a file called hello file. So if I say echo hello world, but instead of making that come out of the terminal window, I'm going to go to a file, hello file. Okay, so now I got no output to the terminal window. And I'm going to do a command that we haven't looked at yet called ls list. So I do ls, and now I see I have this thing called hello file in my directory. And we haven't talked about directories or files yet. We're going to get to that relatively soon. I can use double greater than to redirect as well. And the difference between a single greater than and a double greater than is that the single greater than will overwrite the contents of the file, whereas the double greater than will append or add to the end of the file. So single greater than overwrites the file, double greater than adds to the end of the file. So if I was going to add, if I was going to add to the end of my hello file, I could say echo hello again. And I could, okay, again, that nothing came out, but what should have happened there was this term hello again should have got appended to the end of my hello file, and we're going to take a look here in a minute to see if that actually happened or not. And we're going to use the cat command to see the contents of the file. Cat dumps the contents of a file to the terminal window, or standard out is what it's referred to in Linux world. Cat is, again, another one of these commands that doesn't necessarily make a lot of sense. Turns out that cat is an abbreviation for concatenate. Okay, so what concatenate does is it lets you concatenate files together or merge files together. And so why am I using that command to dump files to the terminal window? Well, if you just use cat with no other, and only list a single file, and you don't tell it to redirect somewhere else, then it's going to dump the contents of the file to the screen. So another bit of trivia, really the important thing to know is that if you use the cat command and then the name of a file, the contents of that file are going to get dumped to the terminal window. So if I say cat hello file, I get hello world. So that's the original, that's the first thing that I redirected into this thing called hello file. And then also I get hello again because my file has this second thing because I use the double greater than sign to append the contents of the second echo into that same file. So that's the cat command, concatenate, cat. You can display the contents of multiple files at the same time by listing more than one file name with the cat command. Must provide a space in between each one. And I would encourage you to create another file called hello file 2. And you know, you should echo some phrase, redirect it into a file called hello file 2, and then try this. I'm not going to do it right now. History is an awesome feature of the Linux command line. It makes your life a lot easier when you get used to using the history command. And so every command that you type in the command line interface is saved to a history file, and you can see your history by using the history command. And the commands are numbered, so you see 1, 2, 3, 4, 5, 6 on this example. So I'm going to do something similar here. I'm going to type in history, and there's the last several commands that I ran. Okay, why is that useful? Well, we'll get to that here in a second. I can execute a specific command again by typing the bang or the exclamation point character. So in computer science circles, you often hear that referred to as a bang, followed by the line number from the history file. You will see the original command followed by the output. Okay, so what does that mean? So let's say I want to execute command number 8 again. So if you look at my terminal window here, command number 8 is the thing that dumps the contents of the hello file to the terminal window, and I can execute that thing by doing exclamation 8. And what happened there was that command was printed to the terminal window, followed by the contents of the hello file. So this makes it easy to rerun commands that have already been run. You can also scroll upward and forward through the commands that you type using the arrow keys. So I can use arrow keys, and you see I'm typing with the arrow keys to move up and down. Let me make my terminal a little bit smaller. There we go. So as I do the up arrow, I'm going through these different commands. So I'm at the very bottom, I hit the down arrow all the way to the bottom. So I have a blank terminal. If I hit up once, I get cat hello file. If I do it again, I get history. Okay. Let me run history again. History. So the last command I ran was history. So if I go up, I get history. If I go up again, I get cat hello file. If I go up again, I get history again. If I go up again, I get cat hello file. If I go up again, I get, so you get the idea, right? Up arrow moves up, down arrow moves down. So if you need to rerun commands again, you can use the up and down arrow keys. You can also go up and you can modify the thing, right? So if you type something wrong, you can do the, so if I typed histor, for example, and I typed enter, well, the histor is not a valid command, so I get this command not found, and I say, well, gee, I typed the wrong thing, so maybe I'll just use the up arrow and then add the Y, and then it works, right? So so this very useful feature. And history-C, history space -C will clear your command history. Help is a cool command that can be used to find common usage and options for a command. So to use the help command, you type help followed by the command you need help with, and you usually will get some help. So here's an example of help history. So I'll do that, help history. And I'm gonna use my mouse to wheelie up here a little bit. Whoops, a little bit too far. So so here's what I get, help history. And then it shows the different command line switches I can use, so -C, -D offset, and et cetera, and so here this tells me what all that means. Display or manipulate the history list. Display the history list with line numbers prefixing each modified entry with a star argument, yada yada yada. And then here are the different options. So -C is going to clear the history list by deleting all of the entries. -D does something else. -A does something else. So so the help command will give me help for these different commands. And I encourage you to try the help command with the other commands that we've run today. Date displays the current date and time of a system. Date, okay, so it's Tuesday, March 17th, 2020, and there's the time, 12:36 UTC. So universal UTC. What is UTC? Universal, whatever. That's Greenwich Mean Time, so it's the time in Greenwich, England. That's 0 time. The cal command displays the calendar, cal, and I get a calendar of this month, right? I can do the -D option to choose a specific month and year, and the format of the month and year is given here: year, month. So if I wanted to know what my birthday next year, what day of the week it was on, I could say cal -D 2021-01, and there's January 2021, and there I can see that my birthday is going to be on a Sunday. How about that? You can also use the Y option to get a specific year. So I can say cal 2022 cal -Y 2022, and boom, there is the calendar for 2022. Okay, so that concludes this discussion of some very introductory level terminal commands in Linux, and hopefully I also provide a little bit of history around the Linux operating system, why you might like to use it, why the bash shell is a thing. And so I would encourage students to now complete the bash basics lab exercise, and you're going to have to get that from your instructor, from your faculty member. All right, so thanks for joining me.